Excitation and ionization of atoms. Energy and potential. Atoms are made up of nucleus and electrons that revolve around it in a fixed levels. These energy levels are like steps of a ladder. An electron can only stand on a step, not in between. To move an electron from one step energy level to another, we must give the right amount of energy. If you give just enough energy to move it to a higher step, another bound orbit, this is called excitation. If you give just enough energy to move it to a higher steps, another bound orbit, this is called excitation. If you give so much energy that the electron jumps completely out of the atom, leaving the atom charged, this is called ionization. If you give so much energy that the electron jumps completely out of the atoms, leaving the atom charged, this is called ionization. The amount of energy needed can be expressed in two ways. If it's energy, the unit is electron volt. If it's potential, it's in volt. Thus, excitation and ionization tells us how electrons move between levels or escapes atoms, which explains many atomic phenomena like spectra, discharge in gases, and even the working of lasers. Hydrogen atom, where Z equals 1, the energy of the electron in the nth orbit is given by a formula minus 13.6 divided by n square electron volt. Based on it, let us draw energy levels. The first energy level, called ground state, has energy E1 equals minus 13.6 electron volt. Similarly, for N2, first excited state, E2 equals minus 3.4 electron volt. N equal to 3, second excited state, E3 equals minus 1.51 electron volt. Similarly, for N4, N5, and then there is a infinite state where the energy is 0. The energy increases when we go to the outer orbits. Let us talk about excitation energy. Energy required to excite an atom from a lower energy state to a higher energy state. Energy required to excite an electron from a lower energy state to a higher energy state is called excitation energy. First, excitation energy. Electrons moves from ground state where n equals 1 to n equals 2. Therefore, E first equals E2 minus E1. E2 is minus 3.4 electron volt minus the ground state energy is minus 13.6 electron volt. When we subtract these two, we get excitation energy for first excitation energy equals 10.2 electron volt. Suppose the electron is in the first orbit and we give 10.2 electron volt to this electron, absorbing this energy, this electron jumps to E2. Let us now learn about second excitation energy. Electrons moves from n equal to 1 to n equal to 3. Therefore, E second equals E3 minus E1. The E3 value is minus 1.51 electron volt minus 13.6 electron volt. The result is E second equals 12.1 electron volt. Second excitation energy 12.1 electron volt. The electron is in the first energy state. Now we supply 12.1 electron volt to this electron. Now it jumps to N equals 3. Now let us learn about excitation potential. Excitation energy per unit charge. Here the unit charge is the electron charge, E. So V first equals E first divided by E, which gives 10.2 electron volt divided by E cancel, we get 10.2 electron volt. Sorry, 10.2 volt. Similarly, V second equals E second divided by E. E second will be 12.1 electron volt divided by E. We get 12.1 volt. So, excitation potential is excitation energy per unit charge. Let us learn the next. Ionization energy. Minimum energy required to completely remove an electron from an orbit. For ground state, the electrons moves from ground state n equals 1 to n equals infinity. So, E ionization equals E infinity minus E1. E infinity is 0 minus 13.6 electron volt. So, E ionization for the ground state is 13.6 electron volt. So, the electron is in the first orbit. Now we supply 13.6 electron volt to this electron. It goes to the infinite state, completely escape from the atom. Now, if it is in the second state, we have to supply plus 3.4 electron volt energy so that the electron in the second state escape to the infinite state. Similarly, for E3, E4, E5. For electron in nth orbit, E ionization will be equal to E infinite minus En. That's equal to 0 minus 13.6 divided by n square electron volt. So, E ionization will be equal to 13.6 divided by n square electron volt. Ionization potential. Ionization energy per unit charge. That is the charge of the electron E. Ionization energy per unit charge is called ionization potential. For electron in nth orbit, we have V ionization equals E ionization divided by charge of the electron E equals 1 upon E multiply 13.6 divided by n square electron volt. Here the charge of the electrons are getting cancelled, so we get V ionization equals 13.6 divided by n square volt. Key values to be remembered. First, excitation energy, where n equals 1 to n equals 2. The value is 10.2 electron volt. First, excitation potential, n equals 1 to n equals 2. Here, it is 10.2 volt. So, excitation energy and excitation potential are having the same number but different in unit. Second, excitation energy, n equal to 1 to n equal to 3, the value is 12.1 electron volt. Second excitation potential is n1 to n equals 3, the value is 12.1 volt. Similarly, let us go for ionization energy from n equal to 1. So, n equal to 1 to n equal to infinity, the value is 13.6 electron volt. Ionization potential from n equal to 1 is n is 1 to n is infinity, the value is 13.6 volt. The values are same, the units are different. Ionization energy from n equal to 2, n equal to 2 to n equal to infinity, the value is 3.4 electron volt. Ionization potential from second orbit is 3.4 volt.